Good afternoon, everyone, and welcome back to another episode of Starry Scoop Live. My name is Caitlin Goulet, and before we begin today's episode, I'd first like to thank Westfield Community Programming, Westfield Technical Academy, Peter Cowles, Brady, LePage, and of course my special guest today, Rich Nugent. But before we begin talking to Rich, I'd first like to go over some recent observing that I've done. Now, I may sound like a broken record, but the rain has dulled a lot of the events recently. But I did head up to the Aruna Hill Nature and Science Center last weekend to attend their Smart Telescope Extravaganza, which it was an event geared around smart telescopes the entire weekend, and I just had a blast. My family and I camped, and you can see the shot of the hill with their various telescopes and different observatories there. And Aruna Hill is really special because it's in a dark sky site, so when the sun goes down, you can look up and see all the stars and deep sky objects in the sky. But during the day, it's in the middle of nowhere, which is a good thing because you can go hiking, there's nature trails, and we can also launch off rockets. We had a rocket building competition, little model rockets, and we launched them. And I think we only lost one, which is good. That's a new record for us. We also had a few presentations given by members of Aruna Hill and special guests. And they were on post-processing, imaging, using smart telescopes, and it was just a blast. Now, the rain did dull the observing at night, but we have hopes for the future. Aruna Hill does throw more events throughout the year. You can find them on Facebook or just Google their name, Aruna Hill Nature and Science Center. It's incoming to Mass, and I had a ton of fun, and I will in the future too. So getting into Rich Nugent. Rich Nugent is my special guest today. Rich, how are you?
I'm well, Caitlin. Thank you. How are you?
Good. We have graduation today, so I'm a bit excited. I'm a junior, so a lot of my friends are seniors, so I'll be saying goodbye to a lot of them.
It's a sad time, but it opens new beginnings, right?
It does.
I'm glad you invited me onto your program, and it's a real honor to be here this afternoon. Let's talk some astronomy.
Yeah. So first, tell me a little bit about yourself and how you got into space and astronomy.
Well, it goes way, way back. I've been interested in astronomy. I'm in space science since I was just really young. My dad would occasionally take my brothers and sisters and me out in the night and show us different things in the sky, and it especially stuck with me. Now, growing up in the '60s, if you even liked a little bit of astronomy, you were in heaven, because every night in the news there was something about the Apollo missions and the race to the moon. And so, as a young kid, my parents got me a telescope probably around it must have been around 1966, maybe, a tiny little refractor. It wasn't really even an astronomical telescope. It was more designed for terrestrial work. But as an enthusiastic little kid, it was more than I needed, so it got me started. I've got new telescopes as time went by, and well, here we are today, so all these decades later. I'm pretty heavily involved in the Amateur Telescope Makers of Boston. I'm a past president, part of the observing committee and the clubhouse committee, and so I keep very, very busy with astronomy. Ever since I retired from teaching, it's been like 9 years. I tell folks I only have to worry about two things: grandkids and astronomy. And so it's all fun. But that's how I got started. And, you and I discussed that we might talk about the moon. And I'm pretty sure the moon was the first thing I looked at with my telescope. I mean, I think it's pretty much the first thing everybody looks at with their telescope, because it's easy to find, right? And we're all very curious about it. And I'll bet everybody out there who's ever looked through a telescope, one of the very first things they've ever looked at was the moon, and they fell in love with it. And so part of my mission is to make people fall in love with the moon again. Some of my friends in the Amateur Telescope Makers of Boston hate the moon because they're deep sky imagers, and of course the bright moonlight washes out the deep sky, and they don't like the moon. I love the moon. I look at the moon every chance I can get. I was looking at it last night. It was beautiful. So I love that part of astronomy. I like to look at all kinds of other stuff as well. I mean, Jupiter is my favorite planet. I've got a whole bunch of favorite deep sky objects and double stars and all that stuff. But I really go back to the moon all the time. I really like it.
Yeah, and you said that the moon is one of the first objects all people look at, and That's the same goes for me. I still remember first light with my telescope. So the first time I ever took it out and looked up, I too had a small little refractor. My aunt gave it to me for my 5th birthday. I know I was 5 years old, and I went outside. It was a cold, crisp, I think, fall night. So I was bundled up, wearing rain boots, and my dad has a photo of me sitting in the dark, just looking through the eyepiece, and I was looking at the moon that night. And Jupiter and Saturn, we tried to find them. I think we did successfully, but the moon is what really stuck with me. Now, when you look at the moon, what do you like to observe? Are there special times to observe it, and are there any craters that catch your interest?
Well, there are. And in recent years, the news outlets and social media have always seemed to hype up the supermoons. So I was going to start to talk about that because I'll bet if you ask just the average person on the street, they want to look at the moon when it's full and big and bright. And that first slide we have is a view of the full moon. I don't know if we can put that up, but there it is. And so social media likes to talk about supermoons. And it turns out that the moon's orbit around the Earth is not perfectly circular. There are some times in the month when the moon is a little bit closer to us, and sometimes during the month when the moon is a little bit further away because it orbits in an elliptical orbit. And as it happens, these days, last many years and some more to come, the full moon coincides with the moon's closest approach to Earth. And so the moon looks bigger and brighter in the sky, and the media has cashed in on that. Ta-da, supermoons. Most people, when they look at the moon, they're familiar with the man in the moon, the dark features on the moon. The reason there are dark features and light features on the moon is because the rocks that make up the surface of the moon are different. The maria, or lunar seas, are the dark parts of the moon that we see. And they're dark because they're just made up of different rocks. They're basaltic lava flows that welled up out of the moon about 2.5 billion years ago. So that's what's mostly familiar to people. Now, when you get a telescope, of course, or even a pair of binoculars, that changes the game, because once you apply a little bit of magnification to the moon, you can actually start to see the craters that are all across its surface. And I think that's what people remember most about their first view of the moon through a telescope, is that there are so many craters, and there they are in stark detail. The moon is only, on average, 239,000 miles away. Now, that's a long way, right? That's almost 250,000 miles. But as things go, it's our nearest neighbor. And so when you take a small telescope, it doesn't have to be a big telescope at all, just a small telescope, and aim it at the moon with just even a little bit of magnification, all of a sudden you can start to see detail that you would have never imagined you'd be able to see. And that's what makes that, I think that's why people fall in love with the moon. It's your biggest bang for your buck. I don't care what you're using for optics. You will see more detail on the moon than any other object you'll ever point your telescope at. This is a picture of a waxing gibbous moon. And when you look at this picture right here, you can see those dark areas that I mentioned, the little round circular features. They're called lunar seas because when astronomers started to look at the moon through telescopes, they noticed that those dark areas looked very different than the lighter areas. There weren't as many craters, and they actually thought they might be bodies of water. And so they have names that some of them are familiar to us, like the Sea of Tranquility, the Sea of Crises, the Sea of Serenity, the Ocean of Storms. They're all named after, they're just named after bodies of water that astronomers made up about 400 years ago. The brighter areas are the lunar highlands. Those are really, really old parts of the moon, 3.5 to 4 billion years old. And they're heavily cratered because during that period of time in our early solar system, there was a tremendous amount of debris orbiting the sun, crashing into things like the Earth and like the moon. That's what produced most of those craters that you see on the moon there. And the Earth was bombarded as well, and we looked a lot like the moon does today way back then. of course, here on the Earth, we have processes that tend to erase things. We have wind and we have water because we have, an appreciable atmosphere. We have, so, wind blows things around, water erodes things away. We have plate tectonics. The Earth is a very geologically active planet. Over long timescales and over hundreds of millions of years, the surface of the Earth changes, as the plates move about. That doesn't happen on the moon. There's no air to speak of. There's no water, and there's no plate tectonics going on. So the craters that we see on the moon are billions of years old, and there they are for us to enjoy. Now, that last picture would be a view that you might get if you looked through a pair of binoculars, where the craters are just starting to become visible because of the aperture of the binoculars and the magnification. When you use a telescope, you can zoom in a little bit closer, like in this picture right here. And so this is a picture of craters around first quarter moon. And there are some interesting features. If you look to the left side of the picture, you can see where it's a line we call the terminator. You can see there's a daytime part of the moon on the right, and it gets darker as you go to the left in this image. And that's because to the left side of the image, the sun hasn't come up yet for objects on the surface of the moon. And if we were astronauts standing there looking to the east, we would see the sun rising up. Now, because there's no atmosphere on the moon, it's typically either light or dark. And you see beautiful relief along the terminator because the sun angle is low. And as you can see in this picture, some of the craters, the inside of the craters are still dark with shadow, but their rims, their raised up rims, are actually catching the morning sunlight, and they shine in the darkness like that. Again, these are all impact craters. The darker area towards the left is the Maria. And one feature that I particularly like to see, down near the very bottom center, see that little black line? That's the straight, and I'm drawing a blank. It's not the straight ridge. It's a cliff. It's about 60 miles long, about 1,000 feet high. And it's a fault on the moon's surface. The material to the surface to the right is a little bit higher than the surface to the left. And these are the sorts of things that I love to look at when I look at the moon through telescopes. You can look at some really small detail. It's pretty easy to see because, again, the moon is so close.
Yeah, I also think that one great thing about the moon is that you get to observe different objects every night. I mean, we get new phases throughout the month, and if you go out every clear night, you're looking at new craters every night. And
you certainly are.
Yeah,
go ahead, Kate. I'm sorry.
One of my favorite objects to catch is the lunar X or the lunar Y. I'm sure you've heard about it. They're only visible for 4 hours every lunar cycle. And they're comprised of mountaintops, mountain ranges that when they're along the terminator and the sunlight is just illuminating the tops of them, you see them as an X or a Y on the lunar surface. And I think that's really cool. And it's fun whenever that 4-hour gap coincides with an observing event. And I can point it out to elementary school kids, older adults, part of the Westfield community, and say, this is the lunar X. This is not like a crater. These are mountain ranges being illuminated by the coincidental sunlight just shining on the tops of them.
The morning sunrise light.
Exactly. And
yeah,
it's just
so
really cool to share with others.
I do. I love to show that the lunar X especially because it's just it's a clair obscura, play of shadow and light. But you're right about going out every single night and seeing different things on the moon because of the phases. Now, believe it or not, there are a lot of folks that actually think the phases of the moon are caused by the shadow of the Earth. But the Earth's shadow only interacts with the moon during lunar eclipses. The rest of the month, as the moon orbits the Earth, it's really the sun-Earth-moon angle that's changing as the moon orbits and goes from new moon to first quarter to full moon to last quarter back to new again. And every single night, you can go out, if it's clear, of course, and see different features on the moon. And every month it's a little different because of the way the moon orbits the Earth. Every single month, even at the same phase, the view is slightly different. And it's an amazing object to observe.
Yeah, and now I have to ask, we've all heard about the lunar landings and the Apollo missions, but can we spot the American flags that those astronauts left behind?
I get asked that question all the time, Kate. And I never tire of answering it. The short answer is no. Even though the moon is the closest object to us, those flags were pretty small. On the first Apollo 11, 12, 13 didn't land on the moon, but they had a flag with them. 14, 15, and 16, those missions had flags that were only 3 feet high and 5 feet wide.
Wow.
On the last mission, they packed up the flag that had hung on the walls of mission control for all the other Apollo flights and brought that one to the moon. It was about 20% bigger. So a little over 3 feet and about 6 feet wide. And from the distance of 250,000 miles, it's impossible to see those things. We have satellites that are in orbit around the moon now that have done some amazing high resolution photography of the lunar surface. And if you go and dig those up out of the internet, they present you with a map of the whole surface of the moon. And if you know where to look, you can zoom right in on the landing sites of the Apollo, and you can see all the stuff that was left behind. And in some of them, you can actually see the flag. I think the Apollo 11 flag actually blew over when they fired up the ascent engine and lifted off the surface of the moon. The gases coming out of that engine, I think, just blew the flag right over. But they're all still there. They're all still there. Hopefully someday we'll be back there to take a look at them again.
Yeah, that would be pretty neat. Do you ever try to find the areas in which they landed with your telescope? I know you can't find the flags, but
I do look at the lunar landing sites. I think the easiest ones are to find. Well, Apollo 11, of course, but there are no landmarks to really identify Apollo 11 because they landed on the Sea of Tranquility in the smoothest, most boring area they could possibly, put themselves down on. But my favorites are Apollo 15 at the Hadley Rill, Apollo 16 at the Descartes region, and Apollo 17 at Taurus-Latreille. Now, I was just looking at the last two last night through my telescope. And if you research Apollo 16, they landed near two craters, North Ray and South Ray. And you can see those in a telescope. They are very bright craters that show up nicely under high lunar illumination when the sun is high in their sky. And so you can see those two little craters. I saw them last night. My favorite place to look is the Apollo 17, the valley at Taurus-Latreille. You can see the geological mountains and structures that they were exploring. North Massif, South Massif, the sculptured hills. It's tiny because it's just a little tiny little patch of lunar real estate. But there it is. You can see it if you know where to look. Another thing I like to look at, if you ever watched Apollo 13, when Jim Lovell looks out the window and he comments, "There's Mount Marilyn, named after his wife." He named it after his wife. And if you know where to look, you can see Mount Marilyn on the surface of the moon. It's on the eastern shore of the Sea of Tranquility. It's a little triangular mountain. You can see it's kind of cool to look at. And I like to show that to people as well.
Yeah, that's pretty cool. I'm not a big moon observer, but I think in the future I'll have to be because it's just a lot of fun. I feel like if you know what you're looking at and you know the story behind why it's significant, that adds a lot to the crater or mountain range that you're looking at. My father and I have dabbled in astrophotography, and we have aimed our cameras up at the moon before, and we've captured some craters and some mountain ranges, and we know the names of them, but knowing a story behind them that you can relate to or that you know about really adds to it. So I will be visiting the moon again in the future.
I like to, I always have a backstory when we go to star parties and do outreach. And if I'm showing the moon, I always have the story of what we're looking at because it makes it more interesting. And I'm usually telling the story to the people waiting in line so they won't get bored waiting in line. But people gasp and they want to take pictures of the moon and they love to see it. One of my favorite things with the moon are, of course, lunar eclipses. And they're not as common as going out every single night and seeing the moon. But sometimes at full moon, when the moon passes through the shadow of the Earth, we see an eclipse. And this may just look like a regular picture of the full moon, but it's in the middle of an eclipse. And if you notice, towards the lower right, there's a nice copper orange color to the moon. And there's an interesting story about where that comes from. If you were an astronaut standing on the moon during a total lunar eclipse and you were looking back at the Earth would be covering the sun. That's why you're in the shadow of the Earth. And when you look back at the Earth eclipsing the sun, what you'd see is the nighttime side of the Earth. The daytime side is on the side facing the sun. But what's in between night and day here on the Earth? Because we have an atmosphere, twilight. And what color are twilights? They're orangey yellow. Some of that light hits the moon. Some of it reflects back to the Earth. And during a total lunar eclipse, we see that copper color, the light from all of the twilights that are taking place on the Earth. Pretty cool, right?
Yeah, it is
I
pretty
think that's
cool.
I think that's very cool, and it's what makes lunar eclipses especially fun because you can never predict for sure what the color is going to look like during an eclipse.
Yeah, it can change
Yeah.
based on the event or by different things happening around Earth. I know that we just had a volcano erupt. I forget where, but I mean, soot in the atmosphere can affect that. It can make it darker. I know that there was one. My friend Richard Sanderson observed it. I think I want to
Hmm.
say in the 80s. And the moon that night was barely visible. Rather than being a copper color, it was a deep, deep red. So you can never predict what they'll look like, and everyone is different.
In the early 1990s, there was a lunar eclipse. It was December of, I think it might have been 92, I think. Mount Pinatubo in the Philippines had erupted a year earlier, and there was so much dust and volcanic aerosols in the Earth's atmosphere that eclipse, total eclipse, was pitch black. You could not see the moon in the sky during totality because there was so little of that twilight light reaching the moon because the atmosphere was clogged up with all the stuff from that volcano. You never know what you're going to get. That's what makes them especially fun to look at. Of course, on the other side of the game, and I don't have a slide for it, but we all love to go to see total solar eclipses, and those only happen when the moon is new, and you have to be in the right place at the right time to see those events. A lunar eclipse, anywhere the moon is above the horizon for observers on the Earth, you'll see the eclipse of the moon because just because of its nature. The moon passes through the shadow of the Earth. It takes a few hours sometimes, and everywhere where the moon is up, if anybody is interested enough to go outside and look up, they see the eclipse. So I bet if you polled the general public, how many people have seen solar eclipses? Not many people will raise their hand. How many people have seen lunar eclipses? A lot of people will raise their hand because it's easier to see lunar eclipses. Yeah, fun stuff, right?
Yeah, yeah, it is. And I will be trying to observe the next one if it doesn't get cloudy and rain.
If it doesn't
There
get
was, yeah, there was one a few weeks, months ago. I tried to hold an observing event with my high school club, and we were out there 2 a.m. to 5 a.m. and we saw nothing. It was clouded out, but I have my fingers crossed for the future.
good. I was out in California for that one, and I was lucky enough that there were breaks in the clouds. Although I did get rained on at one point during the totality, I got rained on, but it passed, and I got to see the eclipse from California. And so see from either side of the United States, the eclipse was visible. Sorry about having to get up at 2 a.m. and, but I always like to say astronomy waits for no one.
Yeah.
And sometimes you do have to set your clock and get up and look at things. But good for you. I'm glad you saw that.
Yeah, it's the fun of it. But
Yep.
with that, I think that's the end of our episode. I'd like to thank you for coming on. This was a great talk. And if you guys would like to catch Starry Scoop, you can find me on YouTube, Instagram, Facebook. I also write a monthly newsletter that's geared towards amateur astronomers, and you can find that on my sites as well. And thank you again, Rich. Have a good
Hey,
day.
you're very welcome. Thanks so much for having me on.